Welcome to this webinar on Scholastic's transition to a digital realm using container-based architectures. My name is Ryan. I am a partner solutions architect with Amazon Web Services. I am joined here today by Mayur, who is a senior solutions architect from Red Hat and a specialist on Red Hat OpenShift, and Yuri, who is a DevOps systems engineer from Scholastic. And we are going to be discussing various aspects of OpenShift as well as the Scholastic journey from a largely monolithic platform to a container-based architecture using OpenShift on top of AWS. In a modern day digital context, businesses have had a requirement evolution. More and more businesses are facing challenges where they need to get feedback from their customer base. This feedback is collected through various means, some of them even through simple mechanisms such as mobile apps, where the customer is able to provide feedback around their experience on the application solutions provided by the customer. Companies need to take this feedback and convert that feedback into ideas, whether these ideas are simple bug fixes or whether they are completely new feature sets or new products. Either which way, a business needs to be able to take this feedback, convert it into ideas, and actually build out on these ideas and get them into the market where customers are able to consume these new features, these new services. Traditionally, this was a very slow process. In a modern day context, the desire is to be able to collect feedback, action those ideas, test, experiment with those ideas, and push them out into production as rapidly as possible. In some cases, we're seeing customers being able to do this at a very high frequency and a very low cadence in terms of getting it out in terms of days. The modern application development goals are to be able to automate and abstract away as much of the heavy lifting for a customer as possible. We really want to find ways to enable customers to focus on what is important to them and their businesses, i.e., have the development and operations teams focus on building out applications that are meaningful to their customers, instead of having them focus on things such as infrastructure or platforms. These modernized development practices focus on three very critical components. Firstly, to shorten the time frame from a conceptual idea to production. This is an interesting change from the past. In the past, we focused very strongly on accelerating development. In a modern day context, we're taking it a step further. We're no longer concerned about simply developing an application or a solution. We really want to see that solution get out into the market in a production context. So not just going from development, but going from testing, from UAT to security assessment, and ultimately into a production context itself. The risks that we typically see with a development process, we want to address those risks, we want to identify them sooner, we want to solve those challenges very rapidly so that we can get into production. And a large part of that's not just the development cycle, but also the security elements. We also continuously want to improve on systems. So once an application has been developed and it has gone into production, that is certainly not the end of the journey. We do want to see an evolution of that software set, and those customer feedback components where customers are saying, this is what we want, this is what's missing, drive that continuous improvement. Over and above that, we do see customers wanting to evolve and streamline their cost, their security footprints, and their agility. In a modernized cloud context, there are several drivers. We're seeing more and more customers move into the cloud, and there are various reasons for this. These may include operational resilience. Customers who typical on-premises data centers are not as highly available as what they can achieve on cloud offerings. Cost savings, the economy at scale, the ability to pay for resources only when you're using them, the ability to scale up and scale down as your business requires that, and based on that, pay only for what you absolutely need when you need it. Better resource efficiency, newer technologies, newer innovations coming out continuously, as well as the ability to be incredibly agile at an infrastructure level, but also at an application level, ultimately aggregating into a much higher agility and the ability to get your ideas built into products and solutions and into the market quicker. And these are the primary drivers that we are seeing with customers moving into AWS. Furthermore, if we look at containers, majority of these customers have selected a container platform to provide them a portability mechanism, a means of packaging up their code, their configurations, all of the dependencies, and ensuring that that application workload can run, whether it is on a developer notebook, whether it is in a development or a production context, whether it is going to run in an on-premises data center, or whether it will run on AWS cloud. Really enabling a agility model, a portability model. Containers themselves, unfortunately, are not enough on their own. We do need a little bit more than just a container runtime. And this is where Red Hat has come into the picture with OpenShift. OpenShift is not simply a container runtime, it is an application platform that caters for various components, focusing on an administrative experience, allowing for developers, operators, as well as security individuals to control various aspects of that application journey. Application services, a lot has been put into OpenShift to enable the development process, as well as to reduce some of the heavy lifting of database and storage mechanisms, as well as the orchestration platform being highly abstracted and simplified. And then, of course, my favorite is OpenShift's ability to provide not just a holistic security platform, but also that of a prescriptive guardrail type environment where protective measures are put in place to guide developers and operation teams as to how best to implement security within their application environments. When we at AWS and Red Hat reached out to customers to validate some of our assumptions, we got some consistent asks from all of our customers. And those asks were very simply, we want agility. We want to be able to get into the market quicker. We want a hybrid experience. Our customers wanted a unified experience, a unified process, whether they were running that application workload on premises or whether that was going to run on top of the AWS cloud. Many customers came forward and said, though they have the ability to take various open source and third-party solutions and integrate them together and basically build them out, the desire was more for a turnkey solution, an out-of-the-box approach, so that less effort was spent in terms of building out the systems as opposed to focusing on building the applications that are relevant to the customer environment. And then again, that prescriptive guardrail desire for security. And OpenShift has, by a long means, been the platform of choice, providing all of these components. When we have a look at container platforms and we look at Red Hat OpenShift, we do see some very interesting industry statistics. Mayur, can you run us through some of the things that you're seeing with your customer base?
Sure, thank you, Ryan. Containers are nothing less than new atomic units on which applications are not just developed, but also deployed. Containers provide unprecedented resilience to these applications. But not only that, they also provide great agility and flexibility to these enterprise applications. So organizations that are leveraging containerization and public cloud by going with AWS and OpenShift have reported to us the benefits that they're seeing in terms of scalability, in terms of security, and in terms of economics. As a result, these organizations are capturing the value of their investments in OpenShift and AWS. And IDC has projected this number to be $10.89 million per organization per year. And most of that comes from enabling development teams to develop applications faster and add features to the applications in a much more timely manner. Also, organizations have been increasing their revenue by focusing on opportunities and delivering applications and going to market in a much more timely manner. Also, we have seen that the employee productivity has increased. And this is because the downtime has gone down with the onset of OpenShift and running on AWS. We've also seen that the IT staff are spending far less time managing and supporting and trying to secure the IT infrastructure because of end-to-end automation provided by OpenShift. And last but not the least is the lowering of the infrastructure cost, not only for development, but also for deployment by moving on to AWS cloud and leveraging the features of OpenShift functionalities. Let me talk about the benefits of Kubernetes. I mean, OpenShift is enterprise Kubernetes plus, right? So let's start with the benefits of Kubernetes. If implemented correctly, Kubernetes offers a great deal of benefits. I mean, in terms of scalability, in terms of workload portability, and separation of concern. Just in terms of scalability, you can deploy Kubernetes on your laptop, or you could deploy it in a cluster with hundreds and thousands of nodes. Also, from a workload portability point of view, you can have your workloads running on-premise, or you could have it on public cloud like AWS, or you could also have it in a hybrid manner where your workload would be running both in your private cloud as well as on your public cloud. And you can scale this as and when you need. Also, Kubernetes addresses the concerns not only of the developers who want to basically bring their applications out faster, but also the operations teams who are looking for more stability. So what are the challenges basically that the enterprises are seeing with Kubernetes? What we have found is the main challenge is with the installation and deployment. IT must validate the host and the right kind of settings that they have to set on the host before they deploy Kubernetes. Also, they have to be concerned about the Linux operating system, whether it's installed properly. All those things are a big concern and a roadblock for enterprises when they deploy Kubernetes. Even while deploying Kubernetes, the right identity and security access must be supplied just so that you can integrate your storage, your networking, and the container registries. In terms of hardening, once Kubernetes is deployed, even to just integrate it, you would need other tools like your monitoring tools, your logging tools, also things like you've got to be concerned about security hardening, and also think about organizations with multiple teams. These organizations are concerned about how to segment the resources, how to do meterings for these various teams within their organizations. Metering and chargeback has been a big challenge for enterprise customers using Kubernetes. Say everything is deployed properly in Kubernetes, we are in production. Even after that, operations have to be concerned about the stack from end to end, right from the operating system to the Kubernetes and the application services that are running on top of it. these need to be constantly patched and updated. And this again is a massive concern for enterprises. So what is not in Kubernetes? If you look at it, developer tools and application services is one thing that is really not part of Kubernetes. Kubernetes is not tested with middleware, databases, or any performance monitorings or solution tools. Additionally, if you want to add a specific editor or an IDE or a testing framework, these are all not part of Kubernetes in general. Even DevOps workflows, for example, CICD workflows and how to build containers and update them, that's not part of Kubernetes. And this is something which both developers and the operation folks seek. The other technologies like the operating system, the storage, and the networking are all necessary to deploy Kubernetes in production, but these are not bundled in. And this is a big concern for enterprise customers. So what you see what you get with OpenShift is an end-to-end solution, which is an out-of-the-box solution which ties all the needs and requirements of the enterprise and fills in the needs which are not currently available in Kubernetes. So that way you have a nice turnkey solution for your Kubernetes applications. Back to you.
So not just OpenShift on AWS, we've had customers who are taking full advantage of OpenShift, but also are consuming native AWS services as part of modernizing their application workloads. Typically, we would see a customer take a on-premises application, move that as a container workload into OpenShift on AWS, and then go through the process of exchanging out database caching layers and various other services in favor of a native AWS service that is managed for them, or it is able to scale, or it has a greater resilience platform. And to assist customers in this, AWS and Red Hat have teamed up to build out the AWS Service Broker as well as the AWS Service Operator, one being a Open Service Broker API implementation and the other being a operator framework which directly interact with OpenShift, allowing dev and operations teams to provision and expose native AWS services to their applications without leaving the familiar interface and process of OpenShift in itself. And these are both open source projects that customers can not only consume, but also contribute with. Right. I think let's bring Yuri into the picture. Yuri is a DevOps engineer at Scholastic. And Yuri, run us through the journey that Scholastic has taken over the last few years in terms of moving from a largely traditional monolithic footprint to a modernized container platform using OpenShift and AWS.
Sure. Thanks, Ryan. So today I'll be talking about Scholastic's journey with OpenShift on AWS. Okay, so a little bit about Scholastic before we get started. As some of you may know, Scholastic's one of the largest children's book publisher companies. We actually have offices and presence all over the world, but are mainly based in New York City. So although it may be surprising, but Scholastic actually has a pretty large tech division, and we do try to work with the latest technologies. We actually began our AWS journey back in 2012 and are now about 95% on cloud. So let's talk about some of the challenges we were facing prior to going to OpenShift. Well, back in 2016, we actually had hundreds of monolithic applications and infrastructure setups. By now, most of us know the negatives of monolithic architectures from like the application standpoint, but there was actually a lot of overhead from the infra side of it as well. So for us, the infrastructure was actually hard to manage and handle. We didn't really have much consistency. So some teams were actually deploying it using automated tools such as Chef or just using bash scripts, while others were just deploying servers and updating them manually. They were doing everything manually. Also, we just didn't have consistencies across environments. So some teams had environments like Dev1, Dev2, QA1, QA2, and so on, while others just had the basic Dev, QA, Perf, Prod, and whatnot. This also, we had a similar issue with monitoring. So teams were using their own tools. So some teams were using tools such as Sensu for alerting, while others were using New Relic for application metrics, and some were just using no tools at all. And finally, one of the biggest issues we had to tackle was the application time to go live. So basically, back then, applications took about 2 to 3 months, depending on the size of the app, to actually go into production. This means the time it took for applications to finally start serving traffic, both internally and externally. The deployments were taking long because each environment had to be built out prior to the deployment, and then the operations team would do the deployments. For us, operational readiness, which meant going through a review of application architecture with the operations team and just making sure all the monitoring was in place, took about 2 weeks. And this was kind of due to the back and forth they had to do. So what were some of the goals? Well, of course, we wanted to move away from the monolithic architecture. We wanted to kind of optimize our infrastructure by densely packing these compute nodes and then just scaling as we needed. Of course, main goal was also to minimize our application time to market, just simplifying the whole process. And also, we wanted to actually create a consistent CI/CD pipeline process. So prior to this, a few teams were using automated CI processes with Jenkins, for example, to build and push their applications and code, but a lot of it was also done manually. On top of that, we actually had no insight into unit code test coverage. So our idea was basically to use these pipelines and force developers to build their code that passed through these proper unit tests before they could deploy their applications. And finally, we just wanted a simple out-the-box solution to deploy, a simple container solution with a friendly user interface, pretty much. So why did Scholastic go with Red Hat OpenShift? Well, first let's talk about the benefits we saw in OpenShift itself. Back then, vanilla Kubernetes was kind of in its infancy, and it came with a lot of overhead bits and pieces. It was difficult to manage and install. So also compared to OpenShift, the UI just wasn't as friendly to beginners, so say the devs. We did POC Tectonic, and it was impressive with its one-click install option, but by that point, we were kind of ready doing development work on OpenShift, so we had settled with it. We saw that OpenShift offered S2I, which we thought was going to be very helpful in just standardizing our images for the CI/CD pipelines. Also, routes were interesting. I remember back then the Ingress object hadn't been introduced to vanilla Kubernetes yet, so basically OpenShift was handling all that for us, which was very attractive. And of course, we also found templates to be useful. Again, there was no Kubernetes native solution. I know, of course, now we have Helm and Customize and whatnot, but back then we ended up going with templates to build out our CI/CD pipelines. And of course, the OpenShift had a pretty friendly user interface. Now, why did we go with the supported model? Well, we were already RHEL customers back then, so going with a trusted company made it an easy decision for us. Now, we actually did try to spin up OpenShift origin clusters, and I remember them breaking due to some internal registry certificate issues. And honestly, back then, we just didn't have enough experience to fix it, so we went with the Red Hat supported model. Of course, deploying everything on AWS was also an obvious choice for us. We had been working with Amazon since our cloud migration journey began back in 2012. So by this time, we had around 85% of our infrastructure already on AWS. Biggest benefit is we were able to utilize our existing public and private domains in Route 53 to create the routing for OpenShift. And of course, using wildcards made this very simple for us. So let's talk about the solution implementation here. So for the infrastructure, we actually worked with a Red Hat engineer to get our first cluster set up. Then we built out the rest ourselves. Red Hat pretty much provided all the necessary playbooks for installation, so it wasn't too hard to get everything up and running initially. We did use the Ansible contrib playbooks, which are now, of course, deprecated, but back then they actually installed all the infrastructure and OpenShift using a combination of CloudFormation and Python. The one negative is it did limit our ability to customize, since we did not use the recommended OpenShift, like an Ansible host installation process. But we were able to work around that just by running the ad hoc Red Hat playbooks, as well as just writing our own playbooks to do things such as fix like the update log rotate or set up LDAP, just to name a few. We also did run into issues upgrading clusters, but it was a minor issue really. So since these Ansible contrib playbooks had been deprecated, we kind of had to reverse engineer them a little bit and just update a few packages for the newer version of OpenShift, and then we were able to go get the new clusters up and running. The real issue came up is when we were migrating, and we actually did not have a proper DNS strategy set up, and I'll get into that in just a little bit. So right now, we're actually in the process of migrating to OpenShift 4 and AWS. And so far, their new operator-based installation seems very, refined and useful. We got everything up and running, and so far, we're impressed. So here's a diagram of our basic architecture on AWS. So we actually started off with the recommended 3 master, 3 infra, 3 app node setup, and kind of expanded from there. For the master infra nodes, we used the sizes that Red Hat recommended, which were M4 extra large nodes. Now, for the app nodes, we actually wanted to make them memory specific to fit as many pods as possible. So about 95% or so of our infrastructure microservices were more memory intensive than CPU. So we ended up going with R4 2 extra large nodes for the applications. Now, while our non-prod clusters were fine using the recommended 3 master, 3 infra node setup, for production, we actually scaled up to 5 infra nodes just to have some resiliency for the routers. This was something we did as a precaution since we did have a few CPU intensive pods like Prometheus and Grafana running on the infra nodes, and we did see large CPU spikes. For the application nodes, we were able to scale horizontally as our usage went up, so no issues there. Now, let's talk about our implementation of CICD pipelines. The biggest challenge here was really just getting developers on board, and we ended up going through 3 versions of CICD pipelines. Our first version was kind of just multiple Jenkins jobs that pretty much wrapped the basic OC commands for developers to just build and deploy their applications. We actually did not give them any access to the OpenShift console UI back then, so they just had to run all their commands through Jenkins, which of course you can imagine how difficult it is for developers to kind of figure out, memorize all these jobs and learn it. So the next version, we combined some of these jobs to make deployments a little bit more streamlined. We also gave developers view access in the OpenShift console, so they would be able to view their application logs and metrics, but they still could not deploy from the UI. They still had to remember a few Jenkins jobs to run in the correct order and whatnot, so training was still kind of an issue for us. Finally, in the third version of our pipelines, we actually went with the built-in OpenShift pipelines, which were integrated with Jenkins, and we used the templates to do the deployments. So pretty much it combined the previous jobs in just 2 pipelines. First, there was a single pipeline that devs ran only once per environment. So once per dev, once per QA. This pipeline would just build out all the resources such as the deployment config, the route, and the service. And this was only run once. The second pipeline was a true CICD pipeline. So first, it ran the image builds, and that hooked unit test results into SonarQube. Basically, if their applications failed these unit tests, we would see the results in SonarQube, and they would not be allowed to publish this image and move forward until they fixed it. Once they were able to build their image, they were then able to deploy to various environments. On top of that, we actually were also mounting a new relic jar into each pod. So now devs got app metrics out the box, pretty much with each deployment. So let's talk about some of the lessons learned. There's quite a few, but I'll go into the major ones. So one issue we ran into is actually having very large images. Even though we were using S2I, we were still packing too much into them. One solution for this is, of course, to go with Alpine Linux, and it's something we're still currently working on, honestly. I do highly recommend keeping the images just as basic and minimal as possible, of course. So, for example, our first back to school season back in August 2017, I think, we had a lot of issues with some PHP applications. This was due to the pods being killed and just taking forever to restart, just causing this loop, feedback loop. So back then, we actually did not know any better, and we tried to stuff these old monolithic apps into a container. This meant that these containers were just packed with various bash scripts that were like checking out Git repos and running a bunch of commands, just taking very long to get the application up and running. In retrospect, it may sound dumb, but it's just something we kind of learned with experience. Which brings me to another point. Make sure to add limits to your pods so they don't go rogue and just take over the nodes. During this first outage with the PHP containers, they actually brought down the whole cluster, but we quickly added limits to them. So then we were able to limit the outage to only these containers while the rest of the cluster was up and running fine. Now, I'll talk about the other issue we had with the migration. So looking back at it, I do wish we had thought of a better upgrade and migration strategy in terms of DNS before we built out our first set of clusters. So we did have wildcard DNS entries for all the routes in OpenShift, and this wildcard basically included the cluster name. Now, as you can imagine, when we built out new clusters, that means all the routes had to be changed. This is a lot to ask developers to do, to update their API gateways, to upgrade all their integrations with the new URLs. So, however, we were able to solve this basically by creating a more generic wildcard like star.apps.scholastic.com, for example. And then we were able to delegate the environments in Route 53 by pretty much pointing them to the matching ELBs of each cluster. This made the next migration easier, since now we could pretty much run the same container in two clusters and just use the Route 53 to point to the correct ELB. And finally, for lessons learned, I'd say is just should be open to using new tools. Like before Prometheus was integrated into OpenShift, we actually used a custom Prometheus and Grafana solution for metrics, and it really worked great for us. We also ended up building up our own FluentD forwarder to filter and send logs to Sumo Logic. The one that came out the box from Red Hat was fine. It's just we needed a little bit more customization and had to install some custom gems for this. So what are the results of us going with OpenShift on AWS? Well, one main thing is we created a standardized CI/CD pipeline for all OpenShift deployments, and this made training developers much easier. So whether it was Spring Boot, Python, or Node.js, the pipeline and process was almost identical. So the devs just needed to try it out a few times with our guidance, of course, and then they were able to go out and deploy on their own. The deployments themselves came down to just a few minutes. Pretty much these code commit webhooks triggered the pipelines, which then built the new images, ran the unit tests, and deployed to the dev environment. Once functionality was verified, developers could then deploy to QA, perf, and so on. This also changed how operations worked for us. So since our OpenShift infrastructure was sanctioned by the operations team, when the developers were ready to go to production, they just needed to hop on a call with the ops team to verify all the other components of their architecture, and then they were ready to deploy to prod. So here's an example of what the developers' view today is like. So as you can see, they have a main CICD namespace, and from here they're able to deploy into any other environment. Developers right now do all their own deployments and testing and just need approved change request tickets to get a token to deploy to production. This allows our team to have time and cycles to work on other new things or updates instead of supporting the devs, like we're trying to get OpenShift 4 up right now. Now, one of the biggest benefits we got with OpenShift was, of course, resiliency. So just last Labor Day, when AWS had an outage in one of their data centers, we had a production node go down during our peak back to school time. This means like the time when most kids are actually logging onto our services. Luckily for us, we had no issues on the OpenShift side. The pods that were on that node that went down pretty much just migrated to another node, and there was just no outages for us at all. Another benefit that we kind of took for granted was that OpenShift allowed us to natively plug into our LDAP. So we created groups in Active Directory, then simply mapped them to their respective team namespaces in OpenShift. Each team managed their own groups and access to the namespaces, so that meant just less work for us. Now, of course, the biggest result of going with OpenShift is just a reduced application time to market. It's reduced now down to 2 weeks. So the trained developers now don't need to worry about infrastructure anymore for their microservices. They can just go directly into OpenShift and start deploying and testing them out, even without our involvement. Right now, we have over 200 containers running in OpenShift in AWS, and that number is growing quickly. So we started off with like various old microservices that were just broken off of monolithic apps and then migrated into OpenShift. But today we're actually trying to develop small and nimble microservices. The majority of them are just Spring Boot API backends for the user-facing apps, while the others are either like some front-end Node.js apps or just some Python games such as our Uka Island. We even have some applications that consist of up to 15 microservices, and we're definitely just trying to embrace the microservices model all the way now. So what are some of the next steps for us? Well, of course, we're looking forward to upgrading to OpenShift 4. We see it brings up a lot of new features, and one interesting thing is like that Tectonic had back then that I see Red Hat incorporated now is the being able to upgrade the Kubernetes and the cluster on the go. I think this is huge, and it should definitely save us a lot of time in terms of just upgrading clusters and not having to rebuild new clusters. Also, during our back to school season, actually during both the last two back to school seasons, we did run 2 production clusters side by side, and we could, and as I mentioned, we could manage the traffic through Route 53 and the ELBs. But now we're going to look into doing that permanently, or at least more as needed based on each application. We're also excited to really try out new service mesh tools like Istio, and which is now built into OpenShift. So I think that's pretty cool. And lastly, of course, the open source community constantly develops new and cool tools. And we're just going to continue to experiment and POC them. And if you guys want to learn more about this, just check out these links right here, a little bit more about OpenShift on AWS. And if you have any questions, please feel free to ask now. Thank you.
Hi, Dimitri, thank you very much for that. You are able to pose questions through your webinar control panel. You will see a questions pane that you can expand, and we will try and get to as many of these as we are able to. If we do run out of time, what we will do is try and collect these questions and address them in an email coming out a little bit later on. Right. So a couple of questions have come in regarding provisioning OpenShift on AWS. One question came in, how can I deploy a small instance of OpenShift on AWS for testing and validation before going into production? There are a couple of things that are available here. Within OpenShift 3X, the slightly older product family, if I was simply a developer wanting to explore OpenShift on a notebook or something, I would simply go and take the OpenShift client tools, install them. I would run a very simple OC cluster up command, and that would give me a single VM or a single EC2 instance that I could explore the product with. Moving to the newer OpenShift version 4, Red Hat have changed the installation process to a operator-based install process. The new installer allows you to basically take a JSON configuration file and go and add into that config file the size and scale of the deployment, whether you want the installer to provision out everything on AWS, such as spin up the EC2 instances for you, or whether you have existing EC2 instances and you simply want the installer to add OpenShift on top of existing underlying infrastructure. But I would say the new OpenShift 4 installer is a fantastic way to just, you'd need to reconfigure that configuration file for a smaller deployment. The default does cater to a highly resilient sort of deployment that enterprises would use for default installation. One of the links that Yuri pointed out during the presentation also draws attention to the AWS OpenShift Quick Start. This is a reference architecture for deploying OpenShift on AWS. It is jointly maintained by Red Hat and AWS. And as we learn things from the market and from our customers, we continuously upgrade this reference architecture. But there is an infrastructure as code template that allows customers to very easily fill in some parameters and build out a production-ready OpenShift implementation. To put it into perspective, that entire process of building out a multi-AZ OpenShift implementation will take about 2.5 hours after you fill in a couple of parameters and click on go. So great way to stand up a POC environment, but also if you're happy with that, you can leave that environment in place as your production starting point. In terms of operating systems that are supported in OpenShift, the OpenShift cluster in itself, so the master and infrastructure nodes, those would typically run on Red Hat Enterprise Linux, but now moving into OpenShift 4, we will see CoreOS being the underpinning operating system technology there. The application nodes, so these are the underlying container hosts running on EC2 that are running the customer's applications themselves. These would typically be Red Hat Enterprise Linux or CoreOS in the environment. Yuri, one of the things he called out was in order to achieve a lighter weight container image, however, in their container image descriptions, they're using other operating systems, not limited to RHEL or a CoreOS platform. Let's see if there are any questions that are directly related to us. In terms of versioning, whether you're running OpenShift on your on-premises infrastructure or whether you're running it on AWS, the versioning is identical. There are not two different versions of the software. You can take the exact same software set and run it on premises and on AWS. That being said, there are customers out there who have been running OpenShift in an on-premises context. They started their journey there and they are now migrating into AWS. These customers may make a decision to use the same version they're using on premises, typically a 3x family, 3.9, 3.10, 3.11, or we would, and then later transition both that on-premises and cloud implementation to a newer version such as OpenShift 4. In other contexts, I'm working with customers where they make a decision to deploy OpenShift 4 onto AWS and then at a later stage upgrade the on-premises environment. But just to reiterate, there is no hard and fast required version differentiation, whether you are on-premises or on AWS. What do we did touch on the operating systems. How to manage databases, messaging services while you are doing container applications. So there are a couple of ways to do this, and it's driven really by customer need and customer journey. So for customers who are running OpenShift on AWS, what I typically see is net new application workloads. So these are new microservices coming into the cloud, running on top of OpenShift. I do see a trend where customers are taking advantage of native AWS services like the RDS relational database service, Aurora, NoSQL implementations like DynamoDB, queuing and messaging systems like SQS and SNS. How they provision and implement these, there's a bit of variety. Some customers are using separate cloud teams to provision out these resources, make them available for developers, and then the developers in their containers are consuming these simply by adding in environment variables within their container definitions. Some more elegant ways of doing this, especially if you are trying to enable your development teams and you're trying to stay within a familiar interface. Things like the AWS Service Broker, things like the AWS Service Operator, providing developers within OpenShift the ability to not only provision those AWS resources, and they would do this in the same way that you would provision any service in OpenShift. So some very simple OpenShift commands around a OC create service, and then you would define a relational database and feed in the parameters to stand up that database. The broker and operator then do out-of-band calls to AWS, API calls through CloudFormation. They provision the resource. Once the resource is available, the broker and operator communicate back to OpenShift, and all of the building blocks required to consume that resource. So the endpoint for talking to a database, the port number, usernames, passwords, any IAM credentials that would be required to consume that resource. These are then stored safely inside OpenShift's secrets manager. And what developers can do is simply do a binding process from that secret to their application, and that will then map the environment variables in their application container to the values that were provided from these brokers and things. And then there are several examples of this available out on the internet, on YouTube. But do go and do a quick search in for the AWS Service Broker or the AWS Service Operator, and you'll get to those open source projects. That being said, in a migration context, we do see a situation where customers are taking application workloads in very much a lift and shift process, where they're taking an existing containerized application running in OpenShift on premises. That workload may have a database attached to it, and that database is running as a container workload. It's typically a MySQL running as a container inside OpenShift. And I have seen customers take those containers for the database and the application consuming it, lift and shift those into OpenShift on AWS exactly as they are on premises, and then at a later stage, spin up a RDS relational database, do a data transfer from the container database to the RDS, and then change the environment variable mappings so that the container workload can talk to the new AWS database, and then they can remove that containerized version. And what this allows them is a managed relational database, including something that scales, something that has multi-AZ awareness, and really taking full advantage of the native AWS services. And we do touch on these sort of concepts in other presentations. So if you hunt around, you will find those. Have you considered Lambda services in your microservices model? This is a question directly to Yuri. I'm going to quickly touch on it. From my side, yes, I do see customers making a decision on, whether an application workload is a good container fit for them, and in which case it tends to run inside OpenShift. Other workloads, if they are shorter running, and fit inside the concept of a Lambda service, are taking some workloads and deploying them in Lambda. I've even seen customers use the built-in OpenShift Jenkins pipelines to cater for both delivery of those. Yuri, just quickly bringing you into the conversation, was there any sort of serverless microservices at play?
Yeah, absolutely, there was. So really the biggest advantage of Lambda is, of course, the integrations with AWS. So we kind of go based off of that. Like if you need to be integrated with the API gateways and whatever internal AWS tools, then yes, we do have a lot of applications running on Lambda. But otherwise, if it's just like regular Spring Boot apps or something, we generally tell them to go on OpenShift. So yeah, we do use both.
Yuri, another question that's coming your way. Can you give us a perspective of the number of developers and contrasting that with the number of operators that are required to run the implementation that you have?
Sure. So developers, we have two main units in OpenShift, business units, and then they're split into various teams. Just off the top of my head, there's got to be at least, I don't know, 30 or more. But in terms of operators, it's just mainly our team. So we did try to hand it off to operations, but honestly, managing OpenShift was kind of huge, and we had the expertise on our team, so we still kind of manage it. While other small things like alerts, like application alerts or whatever, that goes to the ops teams, and then they work with the developers on issues.
Yuri, there's another question here. I just wondered, it's fairly long-winded, so I'm trying to see if I can summarize this. Could you talk more about the code journey from repository to production development? For example, did OpenShift help with canary deployments or code promotion techniques? Is that something that you could shed some light on, Yuri?
Oh, okay, sort of. So we actually, unfortunately, haven't gotten to doing canary deployments yet. Something we've looked into, and we're definitely gonna try it out with Istio and stuff in OpenShift 4. But in terms of the image promotion, we were actually building the images internally in OpenShift in the dev environment. And as I mentioned, once they passed all the tests and developers are ready to promote them, we were then pushing the images to Artifactory. So it's an external registry pretty much. And from there, we were able to basically pull that image that was approved into various environments. So QA, once QA was good, then they could perf test that image, and eventually it could go to prod. So we use Artifactory. We still do use Artifactory as our like central image repo to promote images, but the dev images are actually built in the OpenShift internal registry.
That is a very common pattern I'm seeing on my side as well, where customers are taking advantage of the built-in registry provided by OpenShift, as well as some sort of whitelisting entity. That way the developers are able to develop and play and experiment, and those very unvalidated workloads go into a cluster implementation of OpenShift. And then as they go through unit testing, various code analysis, static code content scanning, container vulnerability scanning. The code is then whitelisted and stored in a whitelisted repository, if you will. Typically, that's something like an Artifactory. And what this means is when a developer starts building a new project, they don't have to start from scratch. They can go to this whitelisted Artifactory location and say, you know, is there something here that has already been partially built out? Has it been security approved and tested? And can I simply consume that and build on top of it? Or do I need to build something completely from scratch, and I can do that in my precursor environment? But the use of different repositories and the use of pipelines are essential to this process. And this is a growing trend within container and DevOps practices. And OpenShift, I'd say, does a phenomenal job of assisting here. But I do want to call out it's not just OpenShift. We're starting to see a lot of things like Artifactory coming into picture, the Quay repository that came in from CoreOS. Also things like the security and vulnerability tools out there, the likes of Twistlock as a partner, for example, assisting with vulnerability scanning. Just touching on, there was a question here, is this a self-managed implementation? OpenShift can be deployed on AWS typically as self-managed, so EC2 instances, OpenShift on top of that, and customers being able to manage this entirely themselves. And the deployment means there's a couple of options, whether you're using AWS Quick Starts or whether you are using something like the new OpenShift 4 installer. There is a managed version of OpenShift available on AWS. It's called OpenShift Dedicated. This is not sold through AWS. You would basically purchase it through your Red Hat account team. It caters for two variants, a standard edition and a cloud choice or bring your own cloud concept. Just to differentiate them, standard edition, very quickly, you sign up for OpenShift Dedicated. Red Hat provision the OpenShift implementation into an AWS account that they control, and the customer simply consumes that implementation by getting access to the API endpoint. This is completely managed by the Red Hat SRE team, so they do the installation, they monitor health, they do any replacement of underlying things, they'll assist in scaling the solution. The cloud choice or bring your own cloud offering, customer gets the same management from Red Hat. The only difference is the customer brings their own AWS account and the Red Hat SRE team deploy OpenShift into the customer's account. And what this means is that an AWS customer now has the ability to take advantage of consolidated billing. They can bring reserved instances into that picture to offset some of the infrastructure costs. They'll have visibility into the account from a auditing and compliance perspective, but in essence, they still don't have to do all of the heavy lifting themselves. So we do have the ability to run OpenShift as a managed or as a self-managed implementation. Are there any CloudFormation templates available to deploy OpenShift on AWS? Yes, there is a quick start solution for deploying OpenShift on AWS. Currently, that supports the version 3 family, and there is a version 4 quick start on its way, and we should see that towards the end of the year. There are an ocean of questions still coming in. I will address one or two more as we are on the top of the hour. What we will do is try and collect some of these questions and get them out to you in the summary email a little bit later on. Just give me a moment or two to try and sift through some of these. Yes, this recording will be available for later consumption or reconsumption. One question around OpenShift versus native AWS EKS, which is the managed Kubernetes environment. AWS, the big differentiator with OpenShift, I would say, or why I'm seeing customers trend towards OpenShift, is that it is a turnkey solution. It's not just a container runtime and an orchestration layer. OpenShift does bring a lot in terms of bundling features together. So there is a built-in pipeline and build process. It's based on Jenkins, but you get that out the box. There is a built-in container runtime, a built-in orchestration, which is based on top of Kubernetes. It's not a exclusively Kubernetes environment where developers, operators need to get really into the weeds with Kubernetes. So OpenShift does bring a lot of abstraction over and above that Kubernetes implementation. And this allows developers and operators to ease some of the pains around storage, some of the pains around the networking that they typically face within Kubernetes itself. The implementation, the install and management process is also greatly simplified. The OpenShift implementation also adds in a lot of simplifications around single sign-on, directory integrations. Yuri did mention this briefly regarding their implementation with Active Directory and how this simplified the journey. There is a built-in monitoring and logging mechanism. So when you're looking at OpenShift and comparing it to EKS, many of these features are available with EKS, but they're not part of EKS itself. You would have to implement other AWS services and integrate them together. Typically code pipeline, code build, ECR as a container registry. You would need to bring in elements of CloudWatch, EKS in itself, and then you would have to go and add in some element of federation. So it's possible, but it's a little bit more effort. It's not a simply out-of-the-box turnkey solution. The biggest differentiator for me, however, on OpenShift is its relevance within a hybrid context. If you're a customer who's running workloads on premises as well as in the cloud, and you want that same experience, that same process, you want the exact same way of doing things, whether it's on premises or on the cloud, OpenShift becomes a very natural solution in that context. You know, yes, you'd have two different clusters, but the process around managing those clusters would be the same on both sides. We do still have a long list of questions here. I will try and address these in the email going out at a later stage. I do want to thank everybody who joined us. It has been a pleasure speaking to you. Yuri, Mayur, thank you very much for giving us insight from both a Red Hat as well as a Scholastic perspective.
Sure, thanks, Ryan, and thank you, everyone.
Thank you, everyone.